Hello, everyone, and welcome to today's Energy Storage News webinar with Enervenue, where we'll be learning about metal hydrogen battery technology. I'm Andy Colthorpe, editor of Energy Storage News and deputy editor-in-chief at Solar Media Publishing. Of course, many people associate the term energy storage with lithium-ion batteries, and that's no surprise given the technology's prominence in the global industry. Nearly all new deployments of energy storage today are based on some variation of lithium-ion battery technology, and for the most part, it's doing a great job of bringing flexibility and storage to electricity grids. However, as we are often reminded, in fact, most of the existing grid storage globally still comprises a much older technology in pumped hydro energy storage. So ultimately, things do change. And while today's market is dominated by lithium-ion batteries, investments in non-lithium technologies, particularly those of the long-duration kind, are also on the rise. According to numbers from Bloomberg NEF, cumulative long-duration energy storage, or LDES, installs surpassed a gigawatt in power output and 8 gigawatt hours energy storage capacity by the end of last year. Now, while that's a relatively minor figure in context of the 42 gigawatts and 99 gigawatt hours of lithium-ion battery storage installed during 2023 alone that Bloomberg NEF tracked, let's not forget that it was a crawl for lithium too before it started running into the lead. And relying on lithium totally, or a combination of lithium and pumped hydro, may not be the best way forward if we are to decarbonize and modernize the electricity system rapidly and at scale. It seems likely both of those legacy technologies will be around for a long while to come, but there will be scope to consider other options, and if we are to invest in those, the time to think about them is now. Even the most cynical of us get excited when we hear about new technologies or new ways of doing things that could challenge existing paradigms. So when a while back we ran an interview with Enervenue's CEO, Jörg Heinemann, a while back, leading with Jörg's statement that the company's nickel hydrogen battery tech could beat lithium ion, many readers took note. Well, the cynicism, or perhaps realism, has to kick in at some point, and so the ball now is firmly in Enervenue's court to prove out that belief, which is why I'm delighted to be joined by today's speakers, who are Brad Dorr, VP of Global Marketing at Enervenue. Hi, Brad. And Spencer Nervig, who is Enervenue's Senior Director of Product Management and Application Engineering. Hi, Spencer. Now, as always, interaction with you, the audience, is very important to us. So please do put your questions for Brad and Spencer into the questions tab on the right-hand side of your screen. We'll try and tackle as many of those questions as we can in the Q&A session following today's presentation. But for those that we don't get to, don't worry, Enervenue will be more than happy to follow up and respond in detail offline after the webinar. And in further interaction, there will also be a quick poll for you to take part in about midway through. So let's all look forward to participating in that as well. And last bit of housekeeping from me, the recording of this session will be available to all registrants along with the presentation slides. And so with that, it's my great pleasure to hand over to the first speaker. Over to you, Brad.
Thanks, Andy. Appreciate the time to present. So thank you to Energy Storage News and for hosting the webinar. We're definitely excited here to talk today about our metal hydrogen technology and how it's changing the market, frankly. Before we get there, I'd like to give the folks on the webinar here a little bit of background on nickel hydrogen technology, where it comes from, and how Enervenue plays into that scenario. Nickel hydrogen batteries were developed by NASA in the 1970s and used throughout the 1980s and 1990s in some really high-profile applications like the Hubble Space Telescope, the International Space Station, and the Mars rover. So it really had a long and proven history of performance, 200 million cycles, hundreds of thousands of charge and discharge cycles over that period of time. But it kind of remained stuck in that NASA, that aerospace application until 2017. Stanford University, led by Dr. Yi Shui, one of the preeminent material scientists in the world, he and his team were looking at technologies. As Andy mentioned, we know we need energy storage on the grid, and we do have lithium ion, and that works great for some applications. We have pump hydro, and that works from applications. We need far more than just a couple options here to really get to where we want to be from a grid standpoint. And so what he did is he looked at that technology and said, hey, we've got a technology that's proven. What can we do to it to really then, make it viable in a commercial sense? And what they did is they pulled the platinum out of the NASA's design, because of course everything NASA does works really well, but it's really expensive, right? And they found that they could reduce the cost of that technology so that it could compete or beat lithium ion in the medium term. And they also found that they could actually improve performance on NASA's original design. So it was kind of a win-win. And in 2020, EnerVenue was spun out of Stanford's Business Accelerator to commercialize technology, and that's what we're here doing today. Today, we're producing our energy storage vessel. It's a commercialized solution. We're moving on to our 4th generation product. We have our pilot line in the Silicon Valley, and we'll be moving to large-scale production next year. So that kind of gives you a primer on who we are and what we're doing. Today, we're deploying our pilot projects across the US and frankly, the world. We've got projects in North America, Europe, South America, Asia, and we're really shipping to utilities, to commercial system owners, testing agencies, and a variety of other energy stakeholders. And while we've been developing that technology and shipping our 1st generation product, we've been building a really robust pipeline. We've been met with a lot of enthusiasm in the market. Well, let's talk about why we've been met with that enthusiasm in the market. What we're trying to do is address some of the key challenges that we see today with current technologies, which might be poor performance in regards to temperature, high degradation or unpredictable degradation, a lot of limitations around how a battery can be used. And of course, this necessitates a lot of engineering, necessitates augmentation and adding battery capacity to meet obligations for a project. And we're taking a different approach. Our technology is really robust. It offers integrators and asset owners a wide temperature range, so it doesn't require the same sort of really robust HVAC systems that the current technologies require. We've got a 30-year, 30,000 cycle life with predictable degradation. And these batteries are really meant to be used and abused, charged and cycled and discharged frequently. So we really give the flexibility to the market. And as Andy mentioned, we're kind of changing what's possible. Today, we are a drop-in replacement for lithium ion, but according to Roland Berger, we're looking out 5 years, 40% of the total energy storage market will be in that longer duration category. And that's something that we do really well. We can do anywhere from 2 to 12-hour discharges. So from an engineering standpoint, that longer life and that more flexible characteristics allows us to participate in that longer duration storage category. And if you look back where we've come in the storage industry, it's really kind of very specific use cases, single functions prioritized. And what this is doing is it's allowing integrators, it's allowing asset owners and energy stakeholders the ability to be much more flexible with how they utilize energy storage technology. So as I mentioned, we can go that longer duration, the 6 hours, the 8 hours, the 10 or 12 hours. We can handle, the shorter, the 2 to 4, but really provide that flexibility for folks that need it. And why does that flexibility matter? Well, today, you can look at driving revenue with, one cycle. With lithium ion, you could potentially do 2 cycles, but it comes with accelerated battery degradation. Because of our long lifespan, we're offering asset owners the ability to participate in multiple markets, to cycle multiple times. So if you wanted to, for example, cycle in the morning and cycle in the evening, and then cycle it a third time in the middle of the night to cover another need. We're allowing that flexibility to do more with the capacity that's available. And again, that ultimately points back to the more cycles you can put on a battery, the more flexibility you have. That's increased potential revenue. What we'll do now is we'll actually talk about our technology here a little bit. As I mentioned, we're on our 4th generation technology of our energy storage vessel. It's a 3 kilowatt hour vessel, which is a 100% increased energy density improvement over our previous version, 150% greater capacity, and 150% more power.
Awesome. And Brad, if I could just ask a bit of a question here, because I think you referred to this a little bit, but I think people really like the story of this, space technology being brought down to Earth. But I guess what people like even more than a good story is, a great, cost-effective and durable technology. But I think what kind of lay behind that realization that this technology developed essentially for applications in outer space could be affordable and scalable. I guess those are the two key things, if adapted for terrestrial use.
Yeah, Andy, we kind of touched on it earlier with the story of Stanford and Dr. Yi Shui and his team. But essentially, as you recognized at the top of the webinar, we're going to need lots of batteries that can charge slow, that can charge fast. We're going to need batteries that can do all sorts of things if we want to get our grid to a point where we're reducing the amount of carbon, we're reducing coal and natural gas plants, increasing the renewable energy integration. So Dr. Shui's team at Stanford again was really looking at, have we overlooked anything that might be beneficial to our grid that we can use in a capacity for stationary storage. Certainly, lithium ion works great for mobile applications. For electric vehicles, it's the perfect solution there. But what about the stationary energy storage market? Is there something that we may have dismissed? And that's where they really came to the nickel hydrogen, the metal hydrogen technology. So really just taking a look at that proven technology, what can we do to commercialize it to make it, give us a cost roadmap that's effective use of that technology.
Awesome. So it really is bringing that technology down to earth, kind of in more ways than one. And just a quick note here as well, Brad, that lots of great questions coming in from the audience. So yeah, looking forward to tackling those. And yeah, why should I be having all the fun asking you guys questions?
Great. Yeah, thanks. And as we mentioned the terrestrial applications, what are we talking about? All right, we're not talking about the mobile stuff. We are talking about stationary energy storage. We're talking about grid scale, commercial and industrial, and longer term in the residential market as well. And those, interestingly, those commercial, the C&I and the residential markets offers something called building integrated energy storage, or because of our fire safety properties that we'll talk about a little bit later, we're able to install these energy vessels in places that you might not be able to put lithium ion, in basements or attics, or places where that really long lifespan that doesn't require service or that enhanced safety really makes a difference. So today we're focused on the grid scale and the C&I markets, but again, we see applications for this technology across all stationary use cases. So wanted to touch briefly on the kind of the key benefits of that technology and our energy storage vessel. That's the ultra long life, that's the superior fire safety, the flexibility we've talked about a little bit, the reduction in risk, and overall that lower lifetime cost. So when we talk about that ultra long life, we're talking about being able to cycle this thing all the time. 3 cycles per day, no rest. You cycle 3 times per day over 30 years, you get 30,000 cycles. And even at the end of that 30,000 cycles, we're still talking about a battery that has 86% plus capacity. So you have value at the end of that project. And really that superior lifespan eliminates the need for augmentation or gross oversizing that you're seeing with today's projects. As I mentioned, the superior fire safety, there's no thermal runaway risk. So there's far less engineering that needs to be put into a project to account for complex fire suppression systems. So this is a very simple and easy thing to install and to build for the stationary storage market. And Spencer will talk a little bit about how our lab and third-party testing have really demonstrated that fire safety under a variety of conditions. In terms of the flexibility, I did mention it earlier, we do everything from 2 to 12 hours. It's very flexible. So you can charge for 2 hours, discharge for 10. You could do 3 cycles of 4-hour charge and discharge cycles. You can do all sorts of really creative things with this technology. It's very scalable, and it offers a wide temperature range. So we don't, it's a very robust technology. You don't require the same sort of engineering to, again, account for the robust HVAC systems or all of the limitations that you might see with today's current solutions. It really, again, provides a lot more flexibility both today and future proof if new business models evolve um, down the road. Now we'll talk about risk a lot because we're trying to provide a risk-free solution or something that reduces the risk. And we'll stand behind that. We do offer an extended warranty called capacity assurance that will warranty up to 20 years and 20,000 cycles. It's very simple. It's very straightforward. And that'll guarantee up to 88% battery capacity at the end of the warranty. And we could only do that because we already have a proven chemistry. Yes, we are a relatively young company and new to the market as a startup, but you have to remember that we've got hundreds of thousands of cycles of that core chemistry that's been done in aerospace applications over the last 30 years. And ultimately, this always comes down to, that's great, you guys sound great, better fire safety, longer duration, but what does it cost? And we can definitely, as we mentioned, we wouldn't be in this business if we didn't have that roadmap and that ability to compete on cost. And what we'll see is that we drive OpEx requirements far lower than what you see with today's technologies. And that provides a real benefit to the market. And it really causes utilities to rethink kind of the project economics of a battery system. As I mentioned, there's no robust HVAC. You're reducing the fire suppression required, and you're delivering your ROI again without augmentation. Now, we talked about augmentation a little bit, but why is that important? Well, it's because the cost of augmentation outweighs all the other direct operating expenditure considerations. So, we know that with today's technology, augmentation is either required or you're doing some sort of like really large oversizing at the start of a project. And so, when you take a look at kind of the cycle life of today's current technologies, you're roughly in the 6,000 to 8,000 range, and it's not necessarily linear. So it provides some real challenges from an OpEx standpoint, and that when you have those challenges, that introduces just a lot of risk. And that takes us to our poll question. So here's where we'd like the audience input on this topic. So you'll have a poll here, question come up, and we'd like you to select what you think is most appropriate in terms of what do you perceive to be the greatest risk in augmenting an energy storage plant's batteries years after commissioning? Is it future pricing volatility of batteries? Is it the availability of components due to supply chain constraints? Is the compatibility issues due to technology advancements made between commissioning and augmentation? Or is it uncertain future financial incentives such as changing tax credits or tariffs or things of that nature? Or is it something else? Is there something else there that's in play? We'd really like your input. So take just a moment and select your answer, and we can talk about the results here in a moment.
That's right, Spencer. Yeah. So, also for the audience's benefit, once the pop-up goes, you can see the poll options on the right-hand side of your screen, next to where the questions are displayed. So, just while the audience are responding to that, and I hope for some great engagement to the similarly to the number of questions that are coming in. So some really good questions coming in as well. But yeah, Brad, I'm just wondering that the NVenue technology has quite a few key attributes and what the company claim to be advantages. So why do you think its potential impact on folks' augmentation strategy is such an important one, to the extent that we've we've subtitled this this very webinar around that kind of thing. And you know, also, sorry, what responses do you kind of hear most frequently in customer discussions?
Yeah, so let's kind of start with the first question there. I mean, when you're talking about an energy project, it's the same as any other basic investment, right? Whether you know, if you equate it to investing in the stock market or purchasing property, an energy project represents risk and it represents returns. And what you're trying to do is you're trying to reduce the risk and maximize your returns. You want something that's predictable and stable. And so augmentation, the reason we talk about it so much is because it's the single greatest risk factor in maintaining a project's expected returns. And so,
Sure.
you know, you look at the poll question here. We're getting some great results coming in on what that looks like and what people are most concerned about. But it really is augmentation. We talk about it a lot because it's the number one topic that comes up from our customers.
Cool. Okay. And sorry, and on specifically what your customers, you're hearing from your customers. Let's wait until we've had a bit of a look at the audience's responses, just so that we don't maybe color people's thinking as they're responding to that. So great engagement. Like a majority of the people logged in are actually responding to the poll, which is, yeah, it's incredible to see. So um, what have we got here? So we've got the standout leader response with 41% of the audience vote. Compatibility issues due to technology advancements made between commissioning and augmentation. So it's kind of like the goalpost or the goal line is kind of moving once the project is already in the field. Second, not that close second, but 25% of the audience said that future pricing volatility of batteries might be the greatest risk there. And then with 15% availability of components due to supply chain constraints, followed by that 12% for uncertain future financial incentives, so tax credits and tariffs. I guess if you'd asked this question in 2020, you'd get a very different answer, particularly in the US, to what you have now, post-Inflation Reduction Act. And other, be curious to know what the 7% that responded other might say. So response C, compatibility issues, that was the standout response. Future pricing and volatility of batteries, A, that was second, and availability of components, B, was in third. So just quickly, yeah, is that kind of what you're hearing from customers as well? Is that broadly in line with your expectations, or were there any surprises for either of you?
No, that's definitely in line. I think you know, we see these concerns come up quite a bit, and you know, if we have another commodity run like we saw with the lithium market a couple of years ago, or you know, if you can't procure a compatible container in a timely manner, you know, these are really the consistent themes that come up over time when we're talking about augmentation. So, good job, audience. I think we're spot on reflecting the concerns of the market.
Awesome.
All right, with that, I'd like to turn it over to Spencer, who's going to take us through some of the deployment challenges and how we're solving those as well.
Hey, thanks, Brad. Thanks, Andy, for having us here today. For anyone on the call who's new to us, maybe people heard about Intervenue's technology, let's do a quick refresher just into our battery chemistry. So inside of each of our vessels, we have a stack, cathode and anode. Our cathode is a very well-known, durable cathode. And our anode, right, this is really where our secret sauce lies. This is where Stanford came in and was able to add a new catalyst. Each cathode and anode are layered in between a polymer separator and put into stacks inside of our battery. Looking at our battery, right, this isn't maybe a traditional lithium ion look to it, right? We're a pressure vessel. We have a different state to us, but this actually comes with a lot of safety features and added benefits within that. There's no inherent anything within our chemistry that can catch on fire, but if you were to say, throw our battery into a fire, short circuit it, that polymer separator, it's designed to break apart in that case, your anode and cathode short, bringing a state back to our natural H2O state. What we're actually doing inside this battery is, as we charge the battery, we're actually splitting water. The oxygen from that then combines into the cathode, and you're left with hydrogen gas. So that hydrogen is what puts pressure within our battery. Again, if that's put into a hot scenario or a short circuit, that hydrogen immediately recombines back into water. So we're really a water electrolyte based battery, which is really at the core of our technology and its safety. So how do we take this really safe battery, right? And how do we now put this into a system to get it out into energy storage system? A lot of challenges over the years. It's been great watching the energy storage market grow myself, right? There are many integrators that have really got this down pat, but for a lot of systems out there, right, there's a lot of challenges. We have different technologies we're trying to combine, different fire risk, fire suppressions. So here at Intervenue, what we're really trying to do is how do we build the right solution and leverage our technology with its safety features to really reduce that complexity, to make this much more easy to deploy and put out into the field. And with that, right, I want to talk about our energy rack. This is a great product that's available today utilizing our Gen 4 battery. This is a fully assembled rack that comes out of the factory, plug and play, ready to be deployed. They have 1500 volt and 1000 volt solutions available today. 1500 volt being really the primary driver in the grid scale market. Great voltage range as well out of that. So we're looking around 1100 volts to 1500 volts for our 1500 volt solution. It really ties well with all of the tier 1 inverters out on the market today. And in that 1500 volt solution, we are utilizing 50 of our Gen 4 batteries. Each of those Gen 4 batteries are 3 kilowatts each. So each of these building blocks then come into 150 kilowatt hour capacity.
So Spencer, just a question that I think, judging from some of the audience questions that are coming in, the audience is also maybe sharing some curiosity on this, but you know, a lot of the testing and standards are designed largely around lithium-ion systems, you know, be that systems, cells, and enclosures and components. So how have these kind of been applied and assessed when it comes to the energy vessel and the complete Intervenue solution?
Yeah, great question, Andy. You know, if we look at the standards that are used today for lithium, we look at a lot of UL 1973, UL 9540 tests like the UL 9540A. And while these are traditionally like really what we see for lithium, these standards are actually built to be used around non-lithium as well, right? Plenty of lead acid systems and others in the past. So we're actually lucky enough here at Intervenue with our previous generation 1.2 kilowatt hour vessel. We've already fully completed UL 1973 on that. That's gone through UL 9540A testing. Fantastic results, no fire propagation, no cell to cell problems with that as well. So yes, there are some standards that are lithium specific, but this market, how it's written, how we're always improving, we're really seeing new non-lithium technologies much more easier to certify and get out there.
Excellent, thanks.
So a little deeper look into the energy rack from Intervenue. Really the core building block is a single energy rack. And we'll talk later how we're going to deploy this as a solution out in the field. But these individual building blocks, right, pre-assembled with our BMS fully installed, ventilation fans to keep consistent cell temperature within there. Each of those individual racks then get put together into a cluster. And from Intervenue, this is where our plug and play really comes in handy. We actually provide full harnessing and combining of all your DC connections, your BMS connections, as well as any aux power connections from there. This really will help once we get into a full baked solution to increase that installation time, reduce time in the field making connections, and really have a robust system from there. Another great advantage from us, we can actually stack these. So when we go into higher densities, we're able to stack these 3 rows high. This is, from an intervenue perspective, third-party certified with PE stamp drawings for both seismic and structural. So again, we're trying to take a lot of this engineering work out of the full installation and provide a package that is quickly and easily deployable. And that really goes into that challenge of scalability, right? While lithium, in instances can be stacked, it becomes a much more difficult process to do. Harsh outdoor environments, and again, repeating this on a large scale can often take up much more space than actually required. So what better for an intervenue technology to be deployed than in an energy venue, right? And this concept is really where we have talked to a lot of our customers, talked to a lot of developers to see what makes the most sense to get this out there with the highest density. An energy venue is really, a dedicated building space where you're using our plug and play modules to, again, put these together in clusters and blocks. Each of those blocks can handle on a common DC bus up to 9 megawatt hours. So fantastic systems for long duration, as Brad mentioned. That's a really big driver for us. Each of these vessels is operating in the mid 90s from a round trip efficiency standpoint, which really puts us head to head with lithium far more than other non-lithium competitors out there. Building these energy venue, right, using the building block that we have from a 1 acre perspective, right, you're easily getting 300 plus megawatt hours per acre. Absolutely fantastic for a non-lithium technology coming here. And again, for a long duration, really the best in class from an energy footprint standpoint. Another great way to utilize an energy venue, right, is we can also put this in an existing asset. Maybe you already have an interconnection that's ready to go with existing infrastructure. Very easy for Intervenue to come in, deploy our energy rack, and build an energy venue with that existing infrastructure. We also get a lot of demand from our safety aspects in urban applications. So maybe you have an existing building. Where can we put batteries where traditional batteries on the market today can't be used? Yet another opportunity where Intervenue is a great asset for you. And finally, how, Brad touched on a lot of points of how this long life, how our increased efficiencies really bring a lot of value to this asset. To start off, levelized cost of storage. Because of our low augmentation, high efficiency batteries, you can build now 20, 25, 30-year projects with very minimal overbuild at day one. Reducing augmentation, long duration systems. Intervenue really beats any lithium-ion technology or other energy storage market when you really compare that to the whole life of the system. And going beyond the life of the system, with that minimal degradation, with that high state of health left after the end of time, there's actually value now within this asset, right? This is a new concept we have to often bring to our customers because very much with lithium systems today, you go through them, right? You have to replace them or they'll have a general end of life for them. Being that after 30,000 cycles, we still have 86% health left, you can either reutilize that same asset, move it to a different application, or change it from there. Really looking forward to the questions, Q&A coming up. We're gonna now look into our Intervenue applications back with Brad.
Thanks, Spencer. So we've kind of talked about the technology from that, that 100 kilometers, the 62-mile view of outer space, and we've talked about how it now is being applied to terrestrial applications. Let's talk specifically about where do we really see this technology being used, and where are our customers using it? And so as I mentioned, our markets, we are really invested in the grid scale market. We've got ongoing discussions with developers, with IPPs. We've got a long-term contract signed with a number of customers in this area. We see, we fit really well into that renewable integration space, getting more renewable energy onto the grid. We're really ideal for that longer duration energy storage. As Spencer mentioned, our efficiency, we actually get more efficiency the longer we discharge. So we, you can be a drop-in replacement for projects today that might be, a 4-hour system, but really, we're pushing and changing that narrative to the 6, the 8, 10, 12-hour energy storage applications. And because we've got that proven chemistry already, it really comes low investment risk. There's a reduced OpEx, and without that augmentation, we're providing a safer option. And then lastly, on that grid scale market, we're offering more revenue potential. The ability to stack revenue, the ability to cycle multiple times in a day, really provides value to our those asset owners. I think I saw a question come in on this topic. Are you in play on data centers? And absolutely we are. We see this as an application that's perfect for data centers. I've got a couple stats here about the data center market. There's more than 11,000 data centers worldwide, and today it accounts for about 4% of global energy consumption. But that's climbing due to AI and some other changing requirements around computing power. We're seeing that energy consumption increase. So from 2023 over 2022, we saw a 55% increase in consumption by data centers. And of course, today we can drop in and provide that resiliency and eliminate those peak demand charges, just like other battery technologies. But we're also opening up the ability to play in new energy markets and create new revenue streams with the ability to reserve capacity, eliminate those peak demands, but then also provide another function. We're also providing that improved safety and simplified operations, so you can eliminate your gas backup. You reduce the amount of servicing that needs to be done in your battery systems, and all of this again then plays back into meeting those corporate sustainability goals that are so important today as well. On the large industrial side, I saw another question come in regarding Schlumberger ASLB, who fits within this space. They are an investor of ours, and in fact, we see a lot of oil and gas companies being really interested in our technology. Now, today, oil and gas accounts for about 9%, almost 10% of global CO2 emissions, and there's a huge focus within this group to reduce those numbers. And so again, we see a large number of our investors coming from this space, trying to reduce those carbon numbers, increase the amount of renewable energy that they're using in microgrid projects, in mining applications. They're trying to provide that resiliency, reduce the amount of diesel that's used, but also they understand in energy markets and the ability to play in those energy markets and create new revenue streams with a long-term system that provides long-term value. So as Spencer mentioned, we're really kind of changing the game on how folks think about what do you do with your battery system at the end of that 30-year life. We have value. You can, as Spencer mentioned, it can be repurposed into another application. It can be easily recycled. It can be reconditioned. So there's a lot of things that can be done there. And this group also understands that the reduction in maintenance requirements, what that means. And they have experience with industrial generators, and how do you service diesel gensets in remote locations where you're going to have a system for 20, 30 years. And so being able to reduce those maintenance requirements resonates really strongly with this group as well. And then the last one I'd like to talk about is the EV charging station infrastructure. As we kind of migrate from this oil-based system of transportation to electrification, that requires a lot of conversion of old gasoline-based systems into EV infrastructure, or the creation of new dedicated use EV infrastructure. A recent study from NREL found that the U.S. needs to add more than 1.2 million publicly accessible charging units in the next 5 years just to help get us kind of that next stage of EV adoption. And that's in addition to the 28 million home charging units that are going to be required. Now, the University of Texas did a study that showed electric vehicle adoption alone will increase electricity consumption by 20 to 30%. Now, there's large bottlenecks to installing charging stations and include capacity restrictions and demand charges. And so we're able to utilize our ability in that regards to mitigate those capacity bottlenecks. We also have a really unique ability called building integrated energy storage that allows us to take distressed assets or unused assets, for example, maybe an old gasoline station, and utilize kind of that underground storage area to place our batteries that don't require that servicing, that don't provide that enhanced fire safety, to really kind of find some really unique applications in this space. So we do see this as being a target market, and one again that several of our customers have shown a lot of interest in. So hopefully that's given the audience a good idea of kind of where we're at in terms of the specific applications that make sense with our technology. Now with that, before we get to the Q&A, just wanted to note, we do have some resources available for you if you found any of this interesting. If you have more questions, please visit our website, enervenue.com. We do have a resource center that includes white papers, it includes brochures, technical documents, data sheets, all sorts of videos. This webinar will be posted there, a few days after the conclusion of this call. We do have a newsletter you can sign up for, and certainly follow us on LinkedIn for more information. And with that, we'd like, I think, to turn over to the Q&A portion here.
Fantastic. Thank you so much, Brad, and thank you, Spencer. I think the audience really appreciate the benefit of all the different characteristics of the technology that you've been talking about. And I'm going to be honest, it will be a struggle to get through all of these questions would be entirely impossible. And there's so many that I would say they fall into various different buckets in terms of topic. So we've got some around performance, we've got some around materials, some around manufacturing, some around safety, some on the commercial. Again, so many of those, I'm not going to be able to order them all neatly into kind of sets of categories, but I'll do the best I can with that. And as I did mention before, the questions that we don't get to answer during this session, Enervenue will be more than happy to reach out. You've also got Brad and Spencer's email addresses on the screen there. So let's group some of these performance questions together, and I think that might give us a fairly good shot of answering quite a lot of them. So Enam was asking about, and a couple of the other people were asking about the charge and discharge rate. Enam asked specifically, can it achieve 1C charge and discharge rate? And then Samuel was asking what the power to capacity ratio of the battery unit is, and are there different ratios available? I guess those are sort of related questions, but yeah, what's the deal there, guys?
Yeah, Brad, I think I'll take this one. The first question for more power application 1C. If we look at Enervenue's technology, absolutely we can utilize our technology 1C, 2C. I mean, we've done R&D experience much even greater than that. But our product coming to market today, really where it fits in its current design, right? That's 2 hours C/2 all the way to C/12 is really where that product fits nicely. One other advantage kind of going into the next question to look at from a system deployment, and something that interests a lot of developers looking at different use cases, is our system isn't locked down to any one use case. So the same energy rack that you get can actually be used out of the gate C/2 all the way up to C/12. So now you can actually look at different markets, and maybe throughout the day you can use different flexible. You can do a 2-hour cycle maybe in the morning, a 4-hour cycle later, another 2, a 6. Anyway, within that, right, it all goes into how our battery wants to use. Our batteries love to be cycled, so the more you can do that, right, you would have to cycle this battery 3 times a day for 30 years, right, to get to 30,000 cycles and still have that long life left after that. So hopefully that answers that question as best for today.
Awesome. And in terms of the couple of questions around the round trip efficiency, so Nonso, thank you for your question, Nonso. what is the round trip efficiency?
Yeah, absolutely. So, this is for me really exciting when you look at any non-lithium battery. That's one of the first questions that gets asked because very much a challenge to compete with lithium there. We're lucky here at Intervenue. Our battery is in the mid 90s, right? When we're talking about longer durations, so 6, 8, 10-hour, 12-hour applications. You have less current, obviously, but we're in that 92 to 95 range, and in the high 80s all the way up to our max power. So even at a C over 2, being in the high 80s, great round trip efficiency. So that's something that really differentiates us as well.
Yeah, it does sound pretty strong, doesn't it? Yeah, I think. And a few questions around materials. So I don't know if some of these might be a little bit too technical to go into in a lot of detail within the limited time we have, but yeah, let's see what happens. So Chet was asking, thanks for your questions, Chet. What percentage of the material cost does the nickel represent?
Yeah, I think we can't give a specific number here, but we can say it's a very small percentage.
Okay. I mean, I guess the immediate assumption, and in fact, this is something that I asked your boss Jorg about when I interviewed him a year or two ago. In terms of, we hear obviously there's nickel supply is let's say it's a concern potentially in terms of the EV, but the reply I was given was that the percent, and I don't want to speak on your behalf, obviously, but relatively small percentage in terms of what's required, I guess.
That's correct. And we look at the supply chain for nickel. Nickel's the fifth most abundant element in the world. It's available on every continent. It's an old and established. There's an old and established supply chain for it. So, we found that if you're looking at commodity risk, it tends to be pretty low when we're looking at nickel. Certainly, it's a concern that folks need to be aware of any commodity, right? But when you're comparing again the commodity risk that we've seen, for example, in the lithium market versus nickel, we really haven't run into that same level of concern, if that makes sense.
Yeah, absolutely. So one thing that kind of unites the performance and materials questions was so Mikhail's question regarding the replacement of platinum. So talking about a much more valuable metal, I suppose, but replacement of platinum by other metals is common in the catalyst industry. Mikhail says that this leads generally to lower performance, which potentially could be fewer cycles or less efficiency, and other risks related to supply chain. Not sure if that applies here because Mikhail suggests maybe if cobalt or rare metals are used. What's Enervenue's view on that, and how's Enervenue tackling potential issues around that replacement of platinum?
So I can actually answer that pretty easily. That is our secret sauce, right? That the replacement of the platinum, of course, was done to reduce cost. But what we've actually found is that the metal alloy that we're using as that replacement has not only reduced the cost, but it's actually improved the performance, right? The original NASA batteries didn't have the same sort of efficiency that we're seeing out of the Enervenue technology. So we've actually been able to not only reduce the cost, but improve performance with that change.
Okay. And had a couple of questions in about end of life, and you did refer to the recycling and end of life treatment, but yeah, I don't know if there's any more sort of detail you could offer to audience member Carlos, whose question was, that they would appreciate if you could address the potential recycling at the end of life cycle. So, yeah, I mean, you mentioned abundant materials. You mentioned that it would be relatively easy to recycle, but yeah, how so, I guess?
One thing to kind of keep in mind about the energy storage vessel, it's far less complex than what you see with lithium-ion technology. So those abundant materials are easily recyclable. It's easy to disassemble the energy storage vessel. You're not dealing to the same level of toxicity that you are with the lithium batteries. That being said, the first thing that we need to address is at the end of that 30-year cycle, do these need to be even the end of the 30-year life cycle of a project? Did the batteries even need to be recycled, right? You still have an asset there that has 85% plus capacity. So the health of that battery at the end of the life is still very good. You just might need some reconditioning, and now it goes on to another project or another application. So it's really causing folks to rethink what that end of life looks like, whether it's repurposing or recycling.
Like maybe we'll even be taking them back up to space and using them on Mars, huh? Who knows?
Yeah, could be
30 years time, who knows? Okay, cool. So you did mention the cycling, and the battery likes to be cycled, let's say. But yeah, so Samuel's question, is there a limit on cycles per day? Are there limitations due to things like eventual heating and cooling requirements, or something similar? Like, what would be the max cycles per day? Is 3 cycles per day an average number? Now, Samuel, that's actually 3 questions in one go. But let's see what the guys at Enervenue had to say about that.
Yeah, absolutely, great question. 3 cycles a day is often used by us because, again, that's kind of a new market that's emerging. But depending on your use case, you might be doing solar smoothing, right? You might be doing a bunch of partial cycles all day or frequency response. There really is no limit to us on how we're going to use that battery that way. 3 cycles, especially longer duration, right? You might be limited to how long that capacity is. That's really your only limit there. But even as we test these batteries, right, we run them nonstop. Looking at pilot systems we've put out there in the field today, we appreciate these testings or these utilities that have them. They do their best to run these nonstop, different cycles, different charge rates, different breaks, and it's just been outstanding seeing these in the field really operate actually even better than advertised in these pilot systems. So yeah, no restrictions on cycles at all.
Okay. And a few folks are asking about the manufacturing capability. So Abraham asked what the manufacturing capabilities in the US are, and a couple of other audience members, forgive me, I haven't taken their names, were kind of asking about that. So you mentioned, I think, mass production set to begin next year. So yeah, maybe a little bit of light and shade on those sort of manufacturing plans, I guess, would be great.
Yeah, so we're based currently in Silicon Valley in Fremont, California. That's where our pilot line is, and we've announced plans for U.S. manufacturing in Kentucky. We're moving forward with those plans. We're also looking at international locations. Certainly, a lot of our customers are internationally based, so we're looking at bringing that volume online in 2025.
Awesome. And we had a couple of questions about the pilot deployments, and there's a question just in from Sean, and going to put you guys on the spot with this one. So Sean asks, what have been the biggest challenges you discovered during pilot testing?
I'll come back to the challenges first. Just one quick comment on our pilots. That was, from myself and experience building projects up, how to turn them on large scale. One nice exciting thing about our technology, right? We can ship these fully assembled, drop them in site. So watching these pilot applications where we actually brought these to site, we had our prep work done, we landed them, connected them, and they were actually running that same day. So that was really the most phenomenal thing from there, right? And learning about our technology. But the nice thing for us, right, we've always had improvements now that we've had multiple generations out there. So nothing challenging in the fact that our battery didn't work, but definitely improvements that we can make to our BMS, better cabling, better accuracy, really all of those learnings that have been really great. And putting that into our latest energy rack with our MK7 BMS, it's allowed us from those pilots to really make a robust BMS and product now out of our energy rack.
Cool. Awesome. Okay. And, I think one of the big points that you guys are making, that NVenue is making, is around the safety of the technology. So I think it's only fair to ask a few of these questions that have come in around that. And Hervé was asking, so Hervé suggests that managing hydrogen flow does create its own challenge on safety regulation and fire hazard. What is your comments on this? Is there an element of hydrogen flow management that needs to be taken care of?
Yeah, maybe I'll start this and hand it to Brad to add to it. I saw from a few questions too, and going back to just our general chemistry, how we are in a pressure vessel. One nice thing, right? We are a hermetically sealed pressure vessel. So, there's a question, maybe do we have to add hydrogen? That's not the case at all. So within each individual battery, the hydrogen is really created from that splitting of the water. You split the water, the oxygen goes in your cathode, you're left with that hydrogen gas. And when you then discharge the battery, right, it reverses that. So this can be done repeatedly, millions of cycles from there, but there's really no maintenance on that battery. So nothing to be concerned with adding new hydrogen or managing the hydrogen within there. But outside of that, yeah, absolutely. Simple ventilation techniques. There's, anytime you're looking at the overall energy venue there, you want to make sure that you have proper ventilation within that system.
Okay, and Brad, anything to add on that?
No, I mean, I think Spencer really talked about it. We do see that question come up frequently, because when you hear the word hydrogen, what do you think? But the hydrogen has been used in a variety of applications, including vehicles. And so you've got hydrogen vehicles that are out on the road, dodging new student drivers, dodging the elderly, going 65 miles an hour on the freeway. We're talking about a stationary energy storage vessel that's relatively low pressure, that needs to meet all of the safety requirements as designated by battery system requirements. So, it's a question that comes up, but one that actually is an advantage for us, certainly.
Okay, sure. And on safety, so I think you may have kind of subsequently answered most of this question, because it came in, this question came in midway through the presentation. I think you might have addressed some of these points, but I think they are probably worth going over briefly. So Steve asks, if this is a pressure vessel, why would it not explode under extreme fire conditions? Suppose, for example, it was exposed to fire externally. What is the burst rating of these vessels?
Yeah, so great question, and it kind of actually goes back to what my last explanation. So when the battery is first charged, right, you create hydrogen. That gas builds up. That's actually what builds your pressure up. When you actually throw our battery in a fire, which we've done many times, that polymer separator that I talked about, right, and that heat that's designed to break down, shorting your anode and cathode, that immediately then recombines that hydrogen back into water, right? That actually drops your pressure back down. From there, back in your water-based solution, as that continues to heat, yes, you'll build pressure, but all of our vessels are designed with the right, pressure vessel codes. We have pressure release discs that then again, if that pressure builds up, we will then vent on purpose, right, from more of that water-based solution in the end. So again, in those scenarios, right, throwing those batteries in the fire, that result actually ended up putting the fire out from the source that it was in. So really excited about that technology.
Okay, awesome. That's heartening to know. So folks, we do still have more questions coming in. I think probably in the interest of time, we're gonna have to call it on the dot here. But as mentioned, I think the team at Enervenue will be delighted to follow up on all these. I'm almost tempted to start throwing them at you, but I guess everyone's got stuff to get back to doing. So yeah, with all of that, I just want to thank our speakers today, Brad and Spencer. It's been a real pleasure being on this session with you today and working with you up to this point. But most of all, thank you so much to the audience, and on two reasons really. Number one, for being here and for attending the webinar, and number two, just for being part of this awesome industry. I think it's great. And yeah, thank you so much for joining us today. We'll look forward to seeing you next time.